Thanks for tuning in, guys, to watch this. Pick up these last three problems. Here we go. I want you to find the exact value of the sine of the inverse sine of square root 3 over 2 plus inverse cosine of 1. Well, again, as always, start on the inside and work your way out. Inverse sine of square root 3 over 2, where on the unit circle is sine square root 3 over 2, pi over 3. And this piece here, inverse cosine of 1, where on the unit circle is cosine equal to 1. That's at 0. So I'm asking you to find the sine of pi over 3, which is square root 3 over 2. I don't know if that just changed focus or not. I realized that the top of the hover cam had fallen down, so I erased it up. Alright, look at this next one. Cosine of inverse tangent of 4/3 plus inverse cosine of 5/13. Alright, if we started like the last one, inverse tangent of 4/3. Where on the unit circle is tangent equal to 4/3? Not a nice spot, but it is a position nonetheless. So we can think about this as alpha, and this one inverse cosine of 5/13. Not a nice position, but it is a position or an angle nonetheless, so we can call that one beta. Then what I'm really asking you to do in this is to find the cosine of alpha plus beta, which when we expand that out, that's cosine alpha cosine beta minus sine alpha sine beta. And now if we go ahead and set up alpha and beta, again, I like x, y, r. You may use the right triangles if you like. Inverse tangent is y over x. So y is 4, x is 3. That's a 3, 4, 5 right triangle. Beta it's a cosine is 5/13 x over r, 5/13. That's a 5/12/13. We do need to consider, though, if that should be a positive 12 or a negative 12. And when we think about it, inverse cosine gives an answer in the first or second quadrants. And in the first or second quadrants, the y value is positive. So y is positive here, not positive 12, not negative 12. All right, now just go plug in all this information. Cosine alpha is 3/5. Cosine beta is 5/13 minus sine alpha, 4/5, times sine beta, 12/13. And don't simplify the 5s here, because if you do, then when you multiply them, you won't have common denominators between these two fractions. It's much easier to leave them unsimplified, and that's a 15 over 65 minus a 48 over 65, and there's a negative 33 over 65. Clearly, if this fraction simplifies at the end, then we absolutely would want to simplify that. But there we go. All right, this one, last one. Oh boy, U's and V's. Watch your handwriting, guys. If you're sloppy, be very careful. Put a tail on the U and make your V's pointed. Inverse sine of U, that is an angle. Let's call that alpha. Inverse cosine of V, that's an angle. Call that beta. What I'm asking you to find then is the tangent of alpha minus beta. Expanding that out, tangent alpha minus tangent beta all over 1 plus tan alpha times tan beta. Setting up alpha and beta. Oh, should I do X, Y, R, or should we do right triangles? Well, the last one I did X, Y, R, so maybe this one I should do right triangles, for those of you who like that better. Alright, inverse sine of U. Could be first or fourth quadrant. Let's put it in the first quadrant to make it a little bit nicer to look at. And here's like this alpha angle. Sine is opposite over hypotenuse, so U over 1, which means this piece right here using Pythagorean theorem is the square root of 1 minus U squared. Beta, inverse cosine is first or second. Again, let's put it in the first quadrant to make it nicer to look at. Cosine is adjacent over hypotenuse, so inverse cosine, that's going to be V as the adjacent and 1 as the hypotenuse. Again, using Pythagorean theorem, to go back, this is the square root of 1 minus V squared. Oh boy, this is going to be a mess here, but that's alright, we can handle it. Tangent alpha minus tangent beta. So tangent of alpha, that's opposite over adjacent, so U over the square root of 1 minus U squared, minus tangent beta, opposite over adjacent, the square root of 1 minus V squared, all over a V, all over the denominator 1 plus tangent alpha U over square root of 1 minus U squared times tangent beta square root of 1 minus V squared all over a V. Let's simplify that complex fraction mess. Multiply through by the common denominator, which is going to be V times the square root of 1 minus U squared. Alright, this first one's going to be UV minus, and then this times this, the V's drop out, so we'll have the square root of 1 minus V squared times the square root of 1 minus U squared. You can put that underneath one big square root. 1 minus U squared times 1 minus V squared all over this times that 1 is V square root 1 minus U squared plus, and when we multiply this times that fraction right there, the 1 minus U squareds go, the V's go, and we are just left with U times the square root of 1 minus V squared. Alright, please give a huge sigh of relief, because I am not going to make you rationalize that denominator. It's ugly, but you are done right there. Ooh, I think I lost a parentheses. Right here. Yep. You are done right there. We're good to go. Thank you very much for tuning in.